Okay, ladies and gentlemen, welcome to our last series of presentations of the conference. Just a spot of housekeeping. All of the presentations that have been delivered to date you can find on the conference website. You can get at that via the worldsteel website, or if you Google worldsteel breakthrough conference, that will direct you to the right place. You'll also find the presentation from Helios there. They weren't able to give the presentation at the conference, but if you want to see that, I understand there is a video they've made which is up. So you want to see that, you can go online and watch it. So we will continue with our theme around electrification of steelmaking, and I'm delighted to welcome, probably at some horrible time in the morning, Amar Day from Big River Steel. So Amar's history is international. He studied at the Indian Institute of Technology and also in Ghent. He's worked in SAIL, in ArcelorMittal, and he's now working in Big River Steel, which is now part of US Steel. They describe that as a technology company that happens to make steel. Amar is Director, Product Development and Quality, and he's based in Arkansas. And I hate to think what time it is, Amar, hopefully it's not too bad, but we're very grateful that you were able to join us. So I'm going to step down from the stage now. If you're still going in 18 minutes, I will make some noise so you know to move towards wrapping up. But hopefully, Bradley, we can do what we need to go. If you just, sorry, I think we are advancing the slides for you, Amar, so if you just indicate next slide, then my colleagues can move it on to the next one.
Yeah, that will be it. Thank you. Thank you, Andrew, and thank you, Bradley, and also DIJON, and finally the worldsteel for giving me the opportunity to present this technological breakthrough in the product development. First of all, good afternoon to everybody, and I'm missing very badly the physically being there, and I'm missing Abu Dhabi. So my presentation will be on the new breakthroughs in lean, ultra high strength sheet steel development through arc furnace steel making and through CSP route, but at the same time it guarantees outstanding formability and the steel quality. So the next slide, please. Yeah, just to let everybody know that the Big River Steel, it is located in the mid-south of USA, and it is the LEED certified, the first of the steel plants in the globe to have been awarded LEED certification. That's okay, this slide has some transition effect. And also the last year, it has been also certified with responsible steel making certification. So the current BRS or Big River Steel production lineup is 3 million ton. So the feature is that it's a mini CSP mill. It has two arc furnaces and also LMF, and also it is combined with a RH degasser. So the production lineup is CSP mill, and it comes with associated finishing lines. But one of the interesting feature of this current production lineup is the addition of an NGO line. Next. So just by our the neighboring site, we are having a second mill that is coming up. That's called BRS2 with a 2.8 million ton capacity, and it also has two electric arc furnaces for steel making purposes. The unique feature of this new plant is it runs with the ESP technology, like the ARBEDI, endless strip processing technology, and comes with several newer finishing lines. Next. So to say that total, it will be almost 6 million ton capacity, but all this 6 million ton capacity of steel making will be through only EAF, electric arc furnace steel making. And some of you who have attended last time in the June TECO meeting in Ghent, there was a reference presentation and reference that schematically reference that integrated route of steel making or crude steel making versus 100% scrap steel making. If you see the CO2 reduction emissions, It's almost like 1876 kg of CO2 emission when you make crude steel through integrated route versus 330 kg of CO2 emission through the scrap-based steel making. So almost 1/6 of what is usually emitted through the integrated steel making. So to say that we are already at 1/6 of CO2 emission compared with the other integrated steel making routes. Our process at Big River Steel, we have calculated this year, it's about 410 kg of CO2 emission per ton of hot metal. Next. So just a few things about the arc furnace steel making at BRS, some features to save energy and also make quality steel production. BRS uses a DC furnace technology that reduces flickers and high power input rates. And we also practice a foamy slag practice that with the introduction of our practice of foamy slag, I mean, the arc is shielded, therefore we conserve the heat, and also it saves the refractory life or minimizes the erosion of the refractory life because the heat is kind of shielded or insulated by the slag. And also, since the arc is shielded by the slag, the nitrogen intake in the steel is also low. And there are other good features about the furnace is that it has sufficient volume to accept the full single bucket charge, and also it has an eccentric bottom tapping feature. Next. And typical charge mix is scrap, pig iron, HBI, and our charge mix calculation is based purely on the copper. Copper is the main driving force for the what kind of charge mix we'll be using. We have a low copper charge mix, and also we have a high copper charge mix. And CSPs, as we all know, it has too many recipes, and the challenges are that too many recipes, there are many order book and grades. So one is to switching back and forth between different grades. But also the opportunity is that in the being it is a CSP, so we can make different grades. Just like alternately, we can switch between the grades. That's a good advantage for the CSP. And nitrogen control, wherever it is needed, I mean, we also do by the charge mix calculation. And also, if it is needed very low amount of nitrogen, we take it to the degasser. So next. So if we see the complete production lineup in Big River Steel, so it's a CSP steel production. So after the crude steel is made, so it goes to the LMF, and from the casting to the hot band coiling, you can see it's a continuous process. So there is no loss of heat in cooling down the slab or reheating back to the soaking temperature. So the slab to prime coil yield is almost like 99% here. So the production is very continuous. And because of this continuous nature of processing, immense technological opportunities exist because it's a thin slab caster and also low soaking temperature and very less residence time inside the furnace. So that gives us, as a product metallurgist, we can lean down the chemistry, and also the benefit is that CSPs can cast difficult to cast advanced high strength steels, which otherwise in the integrated way of making, one has to cool down very slowly and also practice reheating back to the soaking temperature. So that kind of is avoided for the continuous steel CSP minimal steel making. So there are many opportunities like exist that to make technological breakthroughs in developing newer products are asking for lesser energy consumption. So I want to talk about one such breakthrough that we have done at Big River Steel. Next. You know, the world, they are likely the most concerned about reducing the CO2 emission. So they are looking for greener steel. And the current perspective in the auto steel demand is they are looking for higher strength steel, and they also need high formability, specifically with regard to the edge stretchability. And they are also looking for greener steel, that is low carbon steel making. And if we consider a typical passenger vehicle, 54% of the lightweighting of a vehicle is by through the use of steels with tensile strength of 450 MPa and higher. And out of that 54%, 25% steel that constitutes steel with tensile strength of 800 MPa, up to 800 MPa tensile strength. And these steels are catered by the introduction of HSLA, dual phase steels, and multi-phase steels. We also call sometimes complex phase steels, and ferritic benetic steel for higher edge stretchability. And next, if we look at these steels, these dual phase, ferritic benetic, or complex phase steels, these steels, in order to guarantee these microstructures, these steels are highly alloyed, and also the cost of production is very high. To generate this microstructure, the second phase microstructure, to get strength and formability, the downstream processing are needed, like very complicated finishing lines are needed to make this microstructure. So the thought process was that, how about taking out the second phase particles and making a single phase ferritic microstructure and get rid of the whole secondary processing lineup. So that's what we are talking about here. Next, please. So at Big River Steel, we have developed a very lean, low carbon, and completely ferritic steel, and that is strengthened by nanoprecipitates of microalloyed carbides, and it is coming with a tensile strength of 780 MPa and with outstanding HER. So you can see the microstructure is totally ferritic, 100% ferritic microstructure, and the strength is derived by the titanium carbide nanoprecipitates. That's about 3 to 4 nanometer in size within the grain. So this microstructure is a single phase, no central line segregation, no banded microstructure, no second phase hard constituents. That gives very outstanding the edge stretchability or the hole expansion ratio. And because it is coming with a very low carbon, so it has the least carbon equivalence for enhanced weldability of the steel. And you can see the chemistry is just carbon manganese, and only the titanium is added to get that nanoprecipitates of titanium carbide. Next, please. And the interesting thing is that this whole microstructure is developed only in the hot band coiling stage. I mean, we don't need any secondary processing for that. The whole strength is obtained in the hot band coils through just controlling the hot rolling parameters and by just adapting to that simple chemistry. We call it single phase nanoprecipitate strengthened steel. So no downstream processing are needed to get that strength or the formability in this steel. So that causes a huge savings in energy, process elimination, lead time increases, and everything else. Next, please. So this is nanoprecipitated strengthened steel is obtained in the hot band coil with the tensile strength of 780 MPa. But if somebody wants it in the coated condition, so this hot band coil can also be taken through a galv line through a very low temperature heat to coat annealing cycle that can coat the steel without affecting any mechanical properties or formability properties. Next, please. So these plots to show on the left hand side, you can see the yield strength and as a function of effective titanium content. So keeping carbon, manganese, and all other elements same. So just by varying the total titanium content in the steel, various steels with various tensile strength levels can be made, like HSLA 70, HSLA 80, HSLA 100. So this steel can be just made with just varying the total titanium content. And on the right hand side, it shows that the different strength level, what is the hole expansion ratio obtained in this steel. And it is also compared with the similar strength at dual phase steel. So at whole spectrum of strength levels, tensile strength levels, you can see the outstanding hole expansion ratio is obtained in these steels. And that kind of that exceeds that hole expansion ratio manifested by DP590 or DP780 steel. So this SP780 steel is a kind of a proper or very apt substitute that will be happening for DP780 steel. Next, please. Yes. So this is not a only theoretical development or laboratory development of steel. This is now commercially being made at Big River Steel. And on the left-hand side, you can see that ultra-high strength, like 100 steel, UHSS 100 steel in the gauge range of 4.5 to 10 millimeter are commercially used by many the OEMs for structural machinery applications, excavators and other, and crane booms, etc. And on the automotive front, so few OEMs are using this for the component of the car seat retractor, then car seat and front link, all these components, and the usage is being developed and increasing day by day. So they specifically the OEMs are trying to explore how they can use this HSL 100 steel for various automotive applications. So these steels are being commercially produced in Big River Steel in a big way now. Next. So in summary, so this technological breakthrough in product processing has been achieved in designing a chemistry and processing a very lean, very low carbon nanoprecipitation strengthened single phase ferritic steel that can yield up to a tensile strength of 780 MPa in both hot roll and coated condition, and can also be achieved in fully processed and coated conditions. So the steel can be also offered in various applicable gauges in hot roll and coated condition, and it kind of eliminates the need for any downstream processing. So the new steel has the potential to replace the medium strength DP steel, CP steels and MP steels up to a strength level of 780 MPa in tensile strength, both in coated and uncoated conditions. And most importantly, the development of steel is made through EAF and CSP route, and hence the greenest of all the steel that is produced with similar strength and permeability properties. Next slide, please. So here are some of the publications and recognitions and awards that has been just cited. You can get it in the presentation later on. But just to mention here that this year, the breakthrough has been awarded the Steely Award for the Innovation of the Year 2023. We are very thankful to the jury members of World Steel Association for honoring us with this great award. Some of the patents have been filed for this product, and some of the patents have been already approved already. So with that, I'll just ask the audience if they have any questions or comments. Thank you.
Thank you. Thank you, Amar, for a very impressive presentation and a great innovation, I think. And maybe a question from me to begin with. Was the development of this product entirely within Big River Steel, or did you partner with academics or any external parties?
No, it was totally within Big River Steel itself.
It's very impressive. Yeah. Do we have any questions? Yeah, a few hands shooting up. Maybe start with, I think it's Alex, in the light over there. Please, Philip.
Thank you. Thank you, Dr. Day, for your presentation. My question is, what are the key metallurgical parameters that you have to control in order to keep those titanium precipitates so small?
Okay, yeah, thank you. That's a great question. The processing of this still is very straightforward. I mean, in the hot rolling condition, you just have to control the finishing temperature and the coiling temperature. So basically, the finishing temperature has to be in such a range, like about like 1550 to 1670 to 1550 Fahrenheit, in that range, so that you don't grow up the titanium carbide precipitates in the hot the finishing deformation stage. What you have to control, cool down very fast from this finishing temperature to the quieting temperature stage, so that most of the titanium remains in solution, but you make the precipitates only in the coil, hot band coil, so that your precipitation occurs in the during the coiling stage and remain very fine, so you don't overgrow the precipitates.
Sorry, thank you.
Thank you for your presentation. I would like to know regard what is the nitrogen and sulfur level and tramp element in your steel in these grades.
Okay, the nitrogen level, normally it is controlled with the like charge mix or also the ferroalloy addition. So we try to keep the ferromanganese, electrolytic ferromanganese to control the nitrogen. We don't degas it, 70 to 80 ppm of nitrogen, but also the more nitrogen means more titanium nitride formation. That way you lose the effective titanium in that. So if somebody wants to control further the nitrogen, it can be degassed. But for our cases, we don't degas the steel. I mean, we always take into account that there will be 80 ppm of nitrogen in the steel. And accordingly, we calculate the titanium, effective titanium in steel. With respect to tramp elements, that are typically whatever the residual tramp elements happens in electric arc furnace steel making. So that some tramp elements are there, but some of the residuals also act in favor of strengthening the steel. So so far we have not been asked to like control any tramp elements from the OEMs.
Okay.
Thank you.
So what is the, you are mentioning that this is a CSP cluster. So what is the mold thickness you are using so that you will not face any, you are casting the sensitivity grades?
Okay, so this steel is not very casting sensitive, as you have seen that it's a very low carbon and just manganese and titanium content steel. But our CSP the mold thickness is, it can go up to 75 millimeter effective thickness, cast thickness. But for these steels, I mean, depending on the gauge, it is axed. So we can go from 75 millimeter, or we can, mostly it is produced with 65 millimeter thick slab thicknesses for 4 millimeter and below gauges. But when it is 4 millimeter and above, we use a thicker mold, that is 75 millimeter.
Thank you.
Thanks, Amar. Thanks for accepting the invitation. I'm sad that you could not join us in person there.
Yeah, you have to make another meeting in Abu Dhabi so that I can join there.
Probably. So my question here is that the presence of the carbides is a very interesting thing that you highlighted there. The liquid metal embrittlement, LME, has plagued the automotive people for a very long time. So do you have any data or anything that you would like to highlight about the weldability of these steels?
Weldability of this steel, we have not, actually most of the parts are being used for that, automotive OEMs for mainly car seat retractor and front and rear links. So weldability, it comes with the least carbon equivalence, this steel, on a 0.5 carbon, and only manganese that governs its this total carbon equivalence value. So the weldability front, it's very easy to weld. It is very easy to roll form also, because its formability is super. And another thing, liquid metal embrittlement. So we have not heard of, or we did not do any experimentation on that. Because this is still at a high strength condition. I mean, we have not got any use in components that needs like coating for this high strength steel. So maybe that will be a kind of aspect we can look into.
I was hoping that you are going to highlight that aspect there, because one of the things that you can do to prevent that embrittlement is the presence of carbides there, depending on their distribution and the size.
Oh yes, I mean these precipitates are so fine in nature, like almost like 2 to 4 nanometer in size. And titanium carbide also, you know, this is a great sink for the you call atomic the hydrogen side. So that will also enhance its any hydrogen related cracking sensitivity for this steel. But definitely, I mean, that will enhance its capability or resistance to HIC or LME kind of defect. But like I said, I mean, we need to study that. I mean, we have not done that, but definitely this still will be very resistant to those kind of aspects.
So it's something next for you to do.
Oh yes.
Thank you.
And thank you, Amar, for a fantastic presentation.
Thank you.
Okay, for the final presentation of my session and the final individual presentation of the conference, we're going back to my island. Scott, I'm going to invite you to join us on stage. So Scott is work manager at Aldwarke Cast Products, which is part of Liberty Steel UK. He's got a very long bio, worked in the UK steel industry for a terribly long time. So part of the Steelmakers Guild in the UK and a past president, so a real expert in our industry and really focused on the role of electric steelmaking, innovation in electric steelmaking as we move forward. Scott's going to talk to us today about the production of safety critical speciality steels from scrap. So Scott, please. I've not had to poke anybody, so hopefully you won't be the first. The floor is yours.
Thank you. Right, good afternoon everyone. My presentation today is focused on the manufacture of aerospace steels for safety critical components produced using the electric arc furnace. I'm Scott Jackson, I'm the works manager at Liberty Speciality Steel. And I'm a proud member of the GFG family. I've worked in the steel industry for 26 years, initially in mechanical engineering, but quickly developed a passion for the electric arc furnace operation and moved into manufacturing. Over the last 15 years, I've directly managed and developed our electric furnace operations, and for the last 5 years, I've been fully responsible for all the melting and casting operations on our site. Many people recognise Sheffield as a steelmaking city, but Rotherham also has a long history of steelmaking, starting in 1823. Originally, Rotherham had 2 blast furnaces, but much like the challenges steelmakers face today, Rotherham converted to electric furnaces in the 1960s, with the Templeborough Works being one of the largest electric steel plants in the world at that time. Once called Steel Peach and Tozer, the legacy of these steel mill owners continues at Liberty Speciality Steel, with our current owner continuing to support the evolution of electric steel making as it becomes carbon neutral. Many of you will have travelled to this conference in an aircraft that contains steel made by Liberty Speciality Steels. Throughout that flight, our steels will have played a major part in ensuring the doors remain closed, the wings control surfaces remain functional, and while we can't guarantee the quality of the landing, however bumpy, our steel will have ensured the landing gear remained intact. Our process route for aerospace steel manufacture uses both merchant and owner-rising scraps, melted by a 165-ton electric arc furnace, refined in the ladle arc before being teamed into ingots. Electric arc furnaces are capable of producing a wide range of steel grades with a low carbon footprint. This includes the steel for safety-critical aerospace applications. Green steel into the aerospace market will ultimately include electrical energy, alternative carbon and gas, all from renewable sources. Our journey so far, from our original carbon footprint analysis on the left-hand side of the chart, includes the implementation of ECOPE 100, work on electrification, and then the efficiency improvements for both electrical and gas consumption. The Liberty Speciality Steel CM30 strategy targets at least a 70% reduction in carbon emissions, but with the possibility of purchasing green gas, a 95% reduction may be possible, minimising the amount of carbon offsetting required to be truly carbon neutral. Aerospace grades present many analytical challenges. There are elements that we can control in process, like phosphorus and sulphur, and those which we cannot control, like copper and tin, where dilution of elements will be required. The scrap used to dilute residual elements is referred to as low residual scrap, and tends to come from the automotive production process in the UK. The availability of low residual scraps can be directly affected by a number of factors, such as reduced automotive manufacturing output in the short term and the forecasted gradual increase in embedded tramp elements. As consumers of scrap, Liberty Speciality Steels recognise these challenges and have a strategy to reduce dependence on low residual scraps currently available in the UK market. Aerospace steels, especially those destined for safety critical components, require a range of mechanical properties and other important characteristics. For example, the 300M grade used for landing gear requires high strength, excellent fatigue performance, while being easy to machine. Although our downstream processes contribute to the development of these characteristics, good analytical control is critical to ensure these downstream processes are effective in achieving the customer's requirements. Our first step in analytical control is scrap selection, something we affectionately refer to as cold steelmaking. This is our view of the UK scrap market, and around 75% of the scrap available is classified as basic. And I've also highlighted the combined maximum expected copper and tin contents. It's also important to recognise that only around 10% of the scrap available in the UK can be classified as low residual. But it's important to remember that this material, again, is affected by automotive manufacturing output, and that 10% is, in our view, the historical best volume available. Scrap processing, sometimes referred to as scrap cleaning, can reduce the copper and tin content of basic scraps, as some of the copper is not embedded and it's present only as components linked to the steel's previous use. These processes can vary in complexity, but all of them essentially liberate non-ferrous metals, leaving electric arc furnace operators with a cleaner, higher yielding scrap that is low in tramp elements, that is as low in tramp elements as possible. The more complex the process, the more non-ferrous material is liberated, and this has a twofold improvement. Firstly, the clean scrap can be used across more steel grades, and secondly, that the embedded copper and tin levels are not increased. Highlighted on this slide is the range of analysis across 98 live aerospace grades currently on offer from Liberty Speciality Steels. Alongside challenging levels of phosphorus and sulphur at the lowest end of the range, you will also recognise the 0.5% variability in copper plus tin across the whole range of grades. Low residual scraps required to dilute the residuals from other scraps are required in volume at the extreme low end of this range. The most extreme example requiring up to 50% of the charge weight to be low residual scrap. With scrap cleaning, it is possible to reduce the overall requirement for low residual scraps. For cast final analysis names in the middle of this product range, and it's even possible to eliminate its requirement in full for analysis aims at the upper end of this range. Processes already used at speciality steels have achieved a reduction in copper and tin of 0.1%, from just under 0.3% to just less than 0.2%. This process involved further processing of fragmented scrap, liberating up to a further 4% of non-ferrous materials by weight. The non-ferrous materials recovered can also be further segregated and sold to generate alternate revenue streams. But importantly, steriles are also segregated, meaning that they do not emit carbon during the steel melting process. They can also be recycled, leaving us as steelmakers with a zero waste process. Our future aspirations are to implement the process route described on this slide. This will enable us to process the vast majority of scrap types available in the UK, especially those generated locally. This reduces the distance our scrap has to travel and contributes to reducing our Scope 2 emissions. These processes ultimately reduce our dependence on low residual scraps and ultimately convert more locally sourced end-of-life steel scrap into safety-critical aerospace components. In summary, even though aerospace steel grades have challenging attributes, mitigations are available to reduce our dependence on inherently low residual steel scraps while reducing Scope 1, 2 and 3 emissions. These processes can also help to slow down and possibly even eliminate the increase of embedded residuals in recycled scrap, a problem many electric arc furnace operators are concerned about. I hope that I've highlighted the capability of electric furnaces to manufacture extremely high quality steel grades with a low carbon footprint. Thanks, and I hope you all enjoy your flight home.
Thanks, Scott. Great presentation.
Thank you.
I think we've all heard the message from outside that, you know, to make really high quality steels, you need ores, you need blast furnaces.
That's it.
I think the last two presentations have shown us that, yeah, you have to work at it.
Yep.
You have to really control your inputs, but there's nothing that we can't do if we really put our minds to it. So, encouraging for the future. Thank you. Do we have any questions for Ed? For Scott, sorry. I don't see any hands up. Maybe I'll ask one. If you look at those grades, Scott, what proportion scrap would you have going into the grades that you're talking about?
So all our aerospace grades are 100% scrap.
100%?
We don't use any hot metal or iron.
Could you see a future when say the UK is making hydrogen DRI, that you would like to use that preferentially, or do you think scrap is...
So scrap is important. There are obviously some grades where analytically even the low resid scraps you're going to struggle, and we have looked at if we went into a different market into slab casting, that we would install a DRI feed into that furnace.
And you probably get fairly margins that many in the room would probably weep at for your really high quality specialist materials. I guess I'll ask you the same question I asked Ed. Could you imagine a green premium for when you get to the sort of extreme right-hand side of the plan that you showed us?
I think that's really important. Ultimately, we need to be carbon neutral as steelmakers. We all recognise that challenge, hence why World Steel's organised this event. But ultimately, the customer needs to value the green steel credentials as well. And we're seeing some, like the aerospace manufacturers, are really interested in green steel because of the difficulties that they face becoming carbon neutral. But ultimately, all steel products, if we can tell the end user, so me and you, that product is green, and is contributing to reducing the impact on climate change, yeah, I can envisage a green premium, yes.
We need to see. Fantastic. I'll just look at the audience once more. Well, we have a gift for you, Scott. Thank you for coming all the way and presenting to us. I'll just put this down. Okay, and with that, final selection of individual presentations comes to a close. Our conference has not yet come to a close. We're going to wrap up, I understand, with a panel discussion. I think we're going straight to that, this one? Yep, I think Wim, you were chairing that. Were you in the room? Ah, there you go. Okay, I will hand over the microphone. Thank you for your attention, and I hope Wim gets the same. All yours.
Thank you, Andrew. And also thank you to the audience to stay for this last panel session of the conference. You must be getting a little bit exhausted because we have had a very rich agenda. We have learned a lot about innovative, novel technologies that will help us to produce carbon neutral, low carbon steel in the future. But during the presentations also some questions have already been raised. Will we have enough renewable hydrogen, green hydrogen? Where will it be produced? How will it be transported? Where we will get biomass? Will we have enough supply of green energy? Lots of important questions we have to ask ourselves. And World Steel has put together quite an interesting panel to have a discussion on this at the end of this day. So I will ask the panel members to come forward. So we have today José NOLDIN, who is the CEO of GravitHy. And we have also Dr. Leandro DIJON, who is the Global Technical Manager, Direct Reduction of Vale. And also we have today Paul ALTSCHWAGER, who is the Chief Capital Officer of Liberty Steel. Welcome, Paul. And last but not least, we also have Andrew GADD, who is the Lead Principal Marketing Sustainability Strategy of BHP. Well, thank you all for joining this interesting discussion. And I'll kick off with the first question, I think, to Leandro. So we talked about the transformation of, let's say, the supply chain of steelmaking in the future. So how are you transforming your business to the shift in the steel industry, and how is your long-term investment strategy changing to that?
Now it's good. Perfect. It's an interesting question because I am an iron maker and I came from a family of iron makers. So my father used to work in the iron making, my grandfather also. So since the very beginning of a young age, I was involved into this iron and steel industry, and I am the first generation who is seeing and witnessing all of this transformation in the iron and steel. And I was lucky enough to work in a company, joined Vale in 2019. And Vale is a company that wants to be a pioneer in this transformation of the iron and steel industry. And looking ahead, it's not unlikely that we might start seeing the shipments of these low carbon metallics from different parts of the globe where we can produce it economically. So if we look in the long run, this might happen, but Vale also wants to accelerate the decarbonization of the iron and steel. And if you want to accelerate the decarbonization of the iron and steel industry, you have to start producing these metallics today. And if we want to do it today economically, we have to look at places where we have availability and affordability of natural gas, where we have good environmental for carbon sequestration, and in the mid to long run, potential to shift to the renewable energy to produce green hydrogen and green metallics. So if we combine all of this with also the logistics and the supply chain constraints, we will feel a few positions in the globe where we can do that. And answering your question about Vale, what Vale is doing now, it's looking at these possible locations and is strategizing or building the investments in these locations so we can accelerate the decarbonization this way. And we have now the steel makers that have to take the decisions of these investments in the next 2 or 3 years. And to do that, they might need to rely on the major technologies, which are basically the direct reduction shaft furnaces and the electric arc furnaces. And for that, they will need a high-grade iron ore. And in this sense, Vale is very well positioned to supply this high-grade iron ore and act as a catalyzer for this decarbonization. So basically, this is the overall strategy of Vale for the mid to long run.
Thank you for that very, very clear answer. So you mentioned you see indeed shifts, you see new locations where you will produce this because you have renewable energy available, high grade ores available. So could we also expect that you see new production hubs developing for this low emission steelmaking? I don't know, Andrew, what is your view on that?
Sure, thanks, Wim. So as Leandro mentioned, it's very important to have abundant low emissions energy for a near zero emissions steel industry in the future. And we think low emissions energy vectors are inefficient to move around to transport. This is because of the conversion losses, chemical conversion or liquefaction. The transport as well, because of the low energy density, is inefficient, and there's complications around the storage and transport safety. So really we want to see the iron making being co-located with the energy sources. And what we see is that those best locations are not necessarily aligned with where we see future steel demand. So I'd mention in particular Australia, but also the Middle East, where we are now, as examples for that. So we could see the hubs developing as a result, and potentially the decoupling of iron making and steel making, so that existing steel making infrastructure can use the low emissions metallics. And I think in particular the Middle East is attractive as it can immediately build out DRI based capacity using natural gas, and then transition later to hydrogen when it becomes economic. A headwind to the hub development though is the trend towards deglobalization. So supply security is a concern for nations and for companies, but this can be mitigated through strong government relations, foreign direct investment, and free trade arrangements.
Okay, thanks, Andrew. I think this is a situation where probably the larger steel makers will be more easy to adapt, but we have also José here, and he's investing in the south of France in a, let's say, location where we probably don't have an existing supply chain. You're probably more exposed to this. So what is the business case for more standalone steel makers?
Thanks, Wim. First and foremost, thanks worldsteel for the invitation. And I hope we all realize how fortunate we are to be witnessing, to be living that a change in such an industry like ours. It's a transformation that it's bringing a lot of innovation in technology, in product, but also in business model. Coming back to precisely to your point, we have the opportunity to redesign the value chain. So it's rather simple. We see that linked with the obligations to decarbonize steel production, we are moving away from 1 million BTUs to kilowatt hours somehow. So the bottom line is not necessarily where we were producing iron in the last 300 years are the good places to produce iron in the future. So there will be opportunities to decouple the value chain, to decouple iron making from steel making. So our business case basically is to be an independent iron producer to be supplying the market with the low carbon metallics, so DRI, HBI, produced out of hydrogen for steel makers that are willing to focus more onto the core business, which is the steel making side. Letting iron, where it makes sense to make iron, it can be themselves investing on their own, or it can be occupied by new players like GravitHy that will actually help them, and steel makers can light the balance sheet and focus on the core business, which is the steel making.
So you see it maybe even more as an advantage to decouple, that you can benefit from the advantages on both sides in the end.
I see that there are many advantages. There are some points of concern as well. For example, in our industry, security of supply is very important. So for you to decouple your iron and steel production chain, you need to be sure that metallics will be there when you need, with the quality you need. So that's a point of concern which is very valid. However, there are many advantages. Now you can move away iron making to where it makes sense to make iron, which is close to natural gas and CCS possibilities. In our case, we believe it's where electricity is available, low carbon and competitive, and bringing something which integrated producers don't know, which is flexibility. Today, for us, an integrated producer, to stop production, to modulate production is a big decision, because to stop a blast furnace is troublesome. It's a big decision. To bring it back is a big investment. It takes time. So to have this flexibility for you to be calling José, market is down, I need less product, it's quite an advantage. And why for the iron maker that's not a problem? Because we are selling a commodity. I will tell you, Wim, I understand, your market is down, so I'm gonna look left and say, okay, construction is actually good, energy is actually good, so selling a commodity gives us the flexibility to be always exposed to some market which will be doing well.
Interesting view. You also mentioned supply chain, secure supply chain is very important. That will be more a topic of a global scale, I think, and probably it will require also some element of international collaboration, partnerships across private and public sector to kind of secure and accelerate this topic. Paul, what is your view on that?
I think collaboration, partnerships, whichever way you describe it, is absolutely essential. I think from my perspective, I'm relatively new into this industry, and I am so excited because you're at the cusp of completely transforming an industry and completely transforming the business model as well. So collaboration, no one individual entity, no one individual steelmaker, not one person in this room can solve this by themselves. So my fellow panelists here have been talking about that. So you're talking about decoupling the supply chain. So, and then you look at the full ecosystem of who's involved. So you go from the ore bodies. So I've got fellow miners on this side here. They recognise that they need to transform their business, but they also recognise that they need to do it in conjunction. They're looking at green iron, they're looking at DRI, we're talking about energy. So therefore, they're looking at modifying their business model. To my right here, we've got a new entrant who's looking to, I won't say disrupt, but it sees that big opportunity there, and it's all on the same parameters. It's the parameters of how do you use cheap, highly available energy to be able to create a product that is essential to decarbonise steelmaking. So it's transforming the steel sector, it's transforming the industry. The parts that we haven't really talked about is what's the role of government? Government is a partner in this. They are a fellow collaborator. The governments need to bring the right policies, the right frameworks. We'll talk about, you can talk about CBAM, but you need to basically allow for steelmakers to transform. The other part is balance sheets. You look at all the major transformations that are occurring. You look at the high-profile H2 green steel. You look at what Salzgitter is doing in Germany. You look at what ArcelorMittal is doing in Canada and Spain. There's significant level of government support because you're transforming a $1 trillion industry. So you actually need the level of government support. So we're trying to do the same thing. We're in a smaller scale. We're actually bringing in partners across the whole eco chain. We have significant mining capabilities in Australia. We're blessed with high quality magnetite iron ore, but we have to expand it. We can't do that by ourselves, so we're talking to offshore customers to come in and partner with us. We're looking at green iron. In Whyalla, we have an abundance of solar and wind, so we're talking to international energy players to partner there. The government, the South Australian government, has done something unique. They're spending $600 million Aussie to build a 250 megawatt electrolyser 2 kilometres from our existing steel plant. And the final part of partnerships, let's not forget, somebody actually has to pay for this. The customers have to go on this journey. We've been asked a couple of times today, will the customers pay a premium? Customers will eventually, I think, I hope. Otherwise, how do we justify this?
Indeed, that's a very important topic you touched here at the end. What will the customer be willing to pay, and will he be willing to pay a premium? So that's indeed a very important topic that we cannot answer today. But maybe let me come back first to the collaboration, the partnerships. I mean, Vale is a very big player today, and I think they will remain also in the future. Do you also see a role for Vale in developing these partnerships? Do you already have maybe some initiatives already ongoing on that area?
Yeah, absolutely. And not only the strategy of building these partnerships, but also the strategy of transforming the company to, instead of being just an iron ore provider, being an iron solutions provider. So we have many different MOUs that we sign with the clients worldwide, but we are not only evaluating the ways of deploying new technologies with the clients to help them to decarbonize, but we are also launching new companies in the market to help these clients to decarbonize. We have a few concrete examples like the BioNow, which is a company that Vale invested to develop the biocarbon technology, and now it's a separate company that can operate in the market and build deploy this technology and even acquire new technologies to produce biocarbon to help the steelmakers to decarbonize. We have Algero, which is a different company that we have recently made a spin-off, which is a company that we invested about 7 years to develop technologies to purify the silica that we produce during the concentration of our products. And so these are two companies, and of course, the product that everybody knows, which is our briquette, the iron ore briquettes that we have. Not everybody knows how this briquette is produced, of the size of the briquettes, of how this briquette looks like. So I have one in my pocket everywhere that I go, so I can show to the people. And in these MOUs that we have with our clients, we have discussions around all of these technologies. We have technology to concentrate iron ore as well, to upgrade the quality of the iron ore that the client might buy in the market. So we work together with them, and we try to find these common configurations where we can have win-win situations and where we can foster the development of this decarbonization. One thing that Paul just mentioned is that the decarbonization is not something that one company alone will do, and we know that. It's not something that a technology alone will do, so it's going to be many different technologies, many different technology providers, and many different companies working together to tackle this challenge. So that's why we believe in this partnership, and we are strongly developing these partnerships, not only with our clients, but also with the metallic producers, governments. Here in the Middle East, we have a lot of conversations going on with the government, with the railway structure, and not only here in the Middle East, but I mean, it's a global company, and we have these initiatives happening everywhere. So it's a lot of effort that we have to put to have these conversations going on. And it's a lot of commitment from the leadership inside the company to make this happen. So this is something very important for us, for the employees inside Vale to see the leaderships engaging in these kind of discussions and taking this decarbonization seriously, and also for the society, because in each of these developments, we are not only promoting the technology advancement, but also the societies around these new developments. And a good example that we have here in these discussions, because Vale has a close relationship with ArcelorMittal in many different projects. We have with GravitHy a project going on also to develop some sort of agglomerates specifically to this venture. We have the same with Liberty, with the green initiatives here in the Middle East. And with BHP, we are fostering the same technologies. We are investing together in Boston Metal, which is the molten oxide electrolysis. We see the same technologies to invest, like Electra is one of the technologies that we discuss. And we are also encouraging the development of these other technologies to help us to decarbonize the steel industry using the medium and low-grade ores as well.
Okay, very clear. Lots of initiatives. Maybe a side question on that. You said it's a lot of effort. Effort is done by people. Do you see a change in your workforce? Do you need to attract other competences than you have had in the past? How easy do you find that to do that?
That is an excellent question, because we see a lot of the clients very concerned about the availability of the iron ore, or the high-grade iron ore. But we are seeing also a concern about the availability of qualified workers, mainly for the ones shifting from blast furnace to direct reduction furnaces. It's not easy to find these professionals in the market. So we have a few cooperations with universities. This year, we have financed 2 PhD students to work in the direct reduction subjects outside Brazil. So it's not only something locally. We also have in Brazil cooperations with the universities to help us to develop even our briquetting technologies and many other technologies. And in all of these cooperations, we try to bring students to start building this knowledge and to attract them to our company. So it's not only iron ore that's going to miss in the future, we're also going to take care of the workforces.
Yeah, I was going to ask you, José, to answer that as well, because you're doing a completely...
No, but I wanted to, if you allow me to on the competences, I like the example. We, for GravitHy, we are a company of 20 people with 7 nationalities. It's amazing, huh? 20 people, 7 nationalities. One guy from Algeria, another one from Egypt, Brazilian, Colombia, Portugal, France, and etc. It's a challenge, but to be honest, I see more as an opportunity, because if we look in the last 20 years, we have been discussing how unattractive the steel industry was because of our image and so on. Today, what we are looking, if we have a forward look, it's about hydrogen, it's about CCUS, it's about green steel, it's about digitalization. We are becoming a very attractive industry, and we have to form these people, because we don't need these guys for tomorrow. We need to develop them for the transition. So I'm rather optimistic on that, because I believe to attract people 10 years ago was a challenge. To attract people today that are willing to take on the journey and to study and to build the right competencies to accelerate and to support our transformation, we are actually very attractive at the moment.
Maybe it also helps that you're wearing this green band, it's CO2 killer, to attract
that's
motivated people.
The armband of the CO2 killers. It's a trademark, so if you want to use it, you have to cash me in.
Maybe now that you're speaking, anyhow, José, you're doing a new project, so probably you are also dependent a bit on funding. And how do you see also the role maybe in the future of green premiums to support your new developments?
Excellent question that I get a lot. We need a lot of things to fall into place for this business model to work. Basically, it's a tripod, right? Where policy, business, and financing, they need to come together. So banks, they need to lend money for this kind of transformation. policies, the legislators, they need to put together the right policies, and I believe we are moving into the good direction in Europe, for example, with the CBAM and etc. And then business will take over with the customers, collaboration with the people that are willing to pay the premium. However, without being too polemic, I want to say that we only need a premium as long as we don't have a formal and global and strong carbon pricing. By the time we have a strong carbon pricing policy that everyone will pay for CO2 emissions, premium will not be there. So if I do my crystal gazing here, I would say that in 10 years we will be in this conference and no one will be discussing green premium, everyone will be discussing penalties. How much penalty are you paying? How much are you paying more? You know, how much is your uncompetitiveness? Because green steel will be the new standard. Until there, yes, we need CBAM to be in place. We need a green premium. We need customers that are willing to walk the talk, step forward, and pay a little bit more for our steel.
I see you nodding, Paul. So I think you have an opinion on that as well.
I certainly do. I think I couldn't agree more with Jose. I think CBAM is one thing. There's actually one thing that's better than CBAM, and it's basically a global carbon price. The issue with CBAM is that it's one jurisdiction. So, and it's designed to protect the European steelmakers. And that's good, but then you need something that's equivalent. The only reason why you have that is because there's not a global carbon price. Now that would actually put everybody on the same level playing field. As sure as the sun will come up tomorrow, that will never happen. There would never be a global carbon price, unfortunately. So therefore, CBAM is actually a necessary evil. And in my view, CBAM should be implemented sooner, not later, not this gradual phase in, because it will accelerate, it will encourage, it will entice, whichever adjective you want to put, it will actually then force people to invest. And that's what's actually needed. So that's where government policy actually is very good. Yes, implementing CBAM will be complex, it'll be costly, lots of admin, all of that, but it's actually it's a necessary evil. You know, from our perspective, how do you respond to that? Well, it's what we've been talking about for the last couple of days. You have to invest. You actually have to invest in low carbon technology. You have to accelerate it. You have to bring in the partners. We could go around in circles there. I would like to see, if you're not going to have a global pricing, we will be agitating for a CBAM in other markets. Because unless everybody is on the same level playing field, you're 80 to 100 euros, 200 euros at some stage disadvantage. And that fundamentally breaks down business models.
Fully agree. And Jose also mentioned we'll be talking about penalties soon. So that's, let's say, a regulation that government imposes. But probably there are also other ways that government can support our transition and innovation. So I don't know, Andrew, if you have a perspective on that.
Look, I think you've said a lot, Paul, on that. That I think we want to see courageous support from governments that really set an environment where steelmakers can commit large capex investments. And so we need clarity on carbon prices, effective market mechanisms in that sense. We need to be agnostic on technologies. Is very important because we don't really know yet how the cards will fall on many of these technologies. So that market transparency on carbon pricing, standards and traceability, supportive trade terms, and targeted subsidies would be important to stimulate investment.
Yeah, indeed. Andrew, you also already mentioned a little bit Asia in your previous answers. A lot of steel is made today in Asia, and you are, of course, well positioned there. Maybe you want to comment a bit more on that.
Absolutely, that's right. The majority of steel made in Asia. The the seaborne market is 1.5 billion tonnes. Most of that being consumed in Asia. A lot of that iron ore supply is coming from Australia. We're producing about 900 million tonnes. And so we need to find solutions that work on those sorts of scales. We need to have low emissions technologies, iron making technologies, that can be built out to the hundreds of millions of tonnes, not tens of millions of tonnes. So that's where we're looking at our ores, which play a very important role in that global market. We're looking for the technologies that fit. Now, we do get asked a lot about upgrading our ores, and that's certainly something that we spend a lot of effort on and have for many years. But the reality is that these ores, not all ores are as responsive to beneficiation. And our ores, while being high grade in the ground and can be mined at a very low cost, very reliably at large scale with low tailings generation, the degree to which they can be beneficiated is modest. We will likely do more of that beneficiation, but we need to have iron making technologies that can use that ore. So we don't really see a revolution happening in the global supply, raw materials supply. We see an evolution in the iron making technologies that can do that, and that's what we'll see in Asia.
Yeah. Now we talked a lot about iron ore, a bit less about scrap. Do you see also changes coming up regarding the scrap usage and supply?
Absolutely, and that's a big dynamic again in Asia. So we see that really scrap's going to be the biggest lever to reducing the average emissions intensity of crude steel production globally, particularly in the sort of medium term, the next 10 years or so. And where we're seeing that in particular is in China. We're expecting to see a large growth in the scrap fund there. And actually that will be sufficient to bring down emissions significantly without the need necessarily for successful low emissions iron making technology over that shorter time period. But that requires support. The scrap infrastructure needs to be developed. Scrap sorting is very important. We've seen presentations discussing residuals, for example, the importance of those on high quality steel production. So that needs to be developed and should be supported.
Wim, I'll just add to that. I think scrap is a key ingredient to this. And I think what you'll see is that increasingly various countries will recognise that. The challenge actually is that there is not enough scrap. And there's not enough of a high quality scrap. So you will see scrap traded prices. It'll trade at an increasingly a premium. So therefore that's going to flow into the supply chain. So there's not going to be, I fully agree with Andrew, is that existing ores will still be the vast majority of the core input into steel making for a very, very long time. They just need the beneficiation of them, the conversion of blast furnace technology to be able to capture carbon will still be a key part of it. Scrap will increasingly with EAFs, but there's not enough scrap. That's where DRI, what GravitHy are doing, will be a key because that's new. DRPs have been around for a long time. Hydrogen DRPs have not. So therefore, it's that emerging technology there with everything else. It'll be a combination of all those.
Very clear, very clear. We have exhausted almost our time, so I'm looking at Rizwan if you have time for a bit of questions from the audience as well. So if there are some questions from the audience, please also direct your question to the panel member that you want. I see a question over there. Second row to the right.
First of all, I think You have mentioned that CBAM is a necessary evil. I'd like to take the necessary part out and also ask you what should be done for global carbon trading market?
Can you repeat your question?
I think he mentioned that CBAM is a necessary evil. I'm saying that I would like to use that, remove that necessary, it's a evil. But what can be done for the global trading market? How can we do that? And see, the level playing field is, across the countries, it is a level playing field for everybody.
The sound here is not very good.
Sorry, I think if I could just, maybe I could interpret that. I think how do you expand CBAM? How do you make it more effective into the other markets? I think it's what you'll have is you'll find one market they'll basically start to implement. So you'll implement CBAM in the European market. You will then see that flow through to other markets. It will never be a fully effective mechanism because you're going to have arbitrage between various markets. And so therefore it's not an effective tool, but unfortunately it's a necessary tool. I know that the Australian government are considering it in Australia. I would imagine that you're going to any place where you actually have imports into those markets that potentially come from high carbon suppliers, the local markets will actually be concerned about that. So it's a necessary evil. That's the only way I could describe it.
I hope that answered your question. Other questions? To the left.
Hello. I want to ask you about Scope 3 emission. What is each company of yours is doing to reduce its Scope 3 emission?
There was a question regarding Scope 3 emissions, but the rest I couldn't hear very clearly.
I would like to know each of the company presented here in the panel, what they are doing to reduce their Scope 3 emission.
Well, I'm from the iron company, and when we talk about Scope 3, it's 97% of the CO2 emissions associated in our supply chain is the Scope 3. So we have a target to reduce 15% of our Scope 3, and we can only do this by engaging with the discussions with the clients and helping them to reduce their Scope 1 and 2 emissions, so then we can reduce our Scope 3. And we can do that by implementing technologies to help them to reduce, like they can substitute a sinter plant with a briquetting plant. That's one way to reduce 15% of the CO2 emissions in a blast furnace route. We can foster the development of the green iron producers, supplying the iron ore for the green DRI producers so they can ship this green DRI to the customers and they will reduce their Scope 3. We are implementing new ways to transport the iron ore in the vessels. So we have I don't know exactly how to describe the bubbles that we inject in the bottom of the vessels to reduce the shear stress during the transportation, and then we can save up to 10% of the CO2 emissions in the transportation, which is also our Scope 3. We have these new rotary fans that we put in the vessels to reduce up to 8% of the Scope 3 emissions. So there are many initiatives from our side that we are doing with the clients, and also developing technologies like the Boston Metal technology, helping to foster this technology so they can be implemented to reduce the Scope 3. That's in our case.
And on a Scope 3, one take I have, for the past few years, I believe everyone was not looking at Scope 3 too much with the idea that, come on, Scope 3 is Scope 1 and 2 of someone else, so let them take care of it. And actually, in our business case, for example, what we see is that there is a big demand for DRI, not only from steel producers, but from final buyers of steel. Because they have to decarbonize their Scope 3, they say, okay, I have to move up into the value chain in order to secure the iron units to help my suppliers to reduce my Scope 3. What I believe is that as long as in the value chain we become more serious, as Vale is doing, for example, on a Scope 3, a lot of movement, a lot of momentum will be built into the decarbonization agenda?
This whole conversation is actually, at the end of the day, is about Scope 3 emissions. You can talk about the technology and all that, but ultimately we're talking about, in our context, creating green steel, not because we want to. Green steel actually is for the customer a decarbonised product that allows them to produce decarbonised products, so reduces the Scope 3. So that's our overarching strategy. So, but you've got to cover every element of the supply chain to be able to ultimately produce the product to sell to a customer who actually then has a green product to use in their own supply chain. So that's how we actually can drive that, by providing the product to them to allow them to decarbonise their businesses.
I'm very glad that you asked the question, because I'm very proud of the Scope 3 decarbonisation program that we have going at BHP. So the way we approach it is very solutions focused. We have a goal of supporting the industry to develop technologies capable of 30% emissions intensity reduction by 2030. And in pursuing that, so far to date, we've spent over $100 million US, and that's moving beyond MOUs and actually putting into action these initiatives. An example is our carbon capture pilot on blast furnace gas that we're doing in partnership with ArcelorMittal and also with Mitsubishi Heavy Industries, and that's going to commission in the next few months. We're also working on an electric smelting furnace pilot. We're in design study phase with Hatch. We have research programs as well with leading institutions. We've been converting our ores, our medium grade ores, into pellet for the first time with good performance of that pellet product in direct reduction, as well as our lump in direct reduction, and also in using hydrogen for that reduction process. We've taken those DRI products that have been produced from our ores and we've successfully electrically smelted them in the lab. And as Leandro mentioned, we are sharing interest in electrolysis technologies and have tested our ores in those processes as well. So a lot going on, a lot more work to do, particularly to scale up these technologies to get them to pre-commercial readiness, but that's the direction we're taking.
Okay, thanks Andrew. Thanks also for mentioning our collaboration project. If you allow me now to maybe wrap up with some key messages. I think we all agree that the supply chain of raw material and energy will drastically change in the coming decades, purely as a consequence of all these new technologies which are being developed and which we have learned a lot the last 2 days. So the suppliers will have to change also their business model, and I've learned that you're already doing this today, so you're actively working on that. We also learned that there will very likely be a disconnect between iron making and steel making, but it does not necessarily have to be a disadvantage. It can also be at an advantage to do that. So I think that was also an interesting learning we had. And I think it was mentioned several times by all the panel members that policymakers, legislation, governments, they will also play a crucial role to support this transition to carbon neutral steel making in the coming decades. So I wish to thank all the panel members. I think it was a very interesting discussion. You learned a lot. So please have a round of applause for our panel members here. Thank you. Let's all stand up and have a picture together.
Well, there is not much left to say. A lot has been said and heard, and I think it will take some time to process and digest all of that information. But what I could do in that meantime is put everything that I heard into some neat baskets. And that will be those of my closing remarks. Some years back, we could hear quite a lot about, in terms of technology development. There was something related with the new products, new steel grades, trying to perfect some existing technologies, but now more and more discussions about technology are always leaning towards the environmental technologies. How do we make sure that the steel industry has got the lowest environmental or CO2 footprint? I think this is some type of a new frontier now. The art of steel making or iron making used to be a closely guarded secret in antiquity. It became a commonly known knowledge, and now we are at that transition or new transformation where we have to somehow reinvent the iron making. And these are very exciting times, and I wish you good luck in that. We heard quite a lot, and we spotted quite a number of those changes that have already started taking place there. I wish you all the best. Thank you very much for all the presenters who really made this conference possible, and I wish you a nice journey back, and I look forward to seeing you at the next event. But before I wrap up, there are quite a few things that are left there. Those of you who have registered for the plant tour, please do not forget to bring your passport and the information that is required by our hosts, and that includes information about your insurance. In the app, you have got 1 or 2 questionnaires. Please do give us your feedback, what type of topics you would like to hear next time around, what we did good, what we did bad, what we can improve on. So that will be a very important bit of information for us, and hopefully we will hear that information from you. I got a question a number of times, when is the next time we are going to meet? So the current understanding is that it will be in 2 years. So that will be the 2-year cycle, and hopefully we will see you next time. And before I say my bye, I would like to invite Edwin Besson. Please, if you can do your closing remarks, that will be very helpful.
Yes, thank you, Rizwan. I'm not going to spend much time. I'm saying just 2 things in closing. Firstly, to Rizwan and his team, I think we should give a nice show of gratitude. I think it was, someone mentioned the word rich program. I agree with that description. It was very interesting, very rich. The arrangements went well, and I thank them all for their attention to detail in terms of the program development, in terms of all of the activities over the last 2 days. Yesterday morning, I opened by saying the focus is about sharing what we know, what is the current state of play, and how to think about the future. I want to thank all of you for the very, very open and rich sharing of ideas. I've been very encouraged by the new strains of thinking that begins to think about what role can we do in terms of using the blast furnaces in a different way. I think we are exploring opportunities for our industry that may not only lead us quicker to the target of decarbonization, but at a much lower cost than was originally thought. I thank you all for being willing to share these ideas. I wish you luck and success with the development of these ideas into commercial activities. And I share the thoughts of the last panel that was here, which said this is a new industry that we are beginning to enter. It is and has always been an incredibly exciting industry. And in the end, we remain one of the core industries that make society, and particularly modern society, possible. So we also have a moral obligation to move forward with responsibility towards the environment, but also move forward with a focus to keep this industry commercially successful. And I've seen all of the elements over the last 2 days that we are well able and well on the way to do that. I thank you all for being here, and I thank you for the openness. Enjoy the rest.